actually stop to look up at the sun and wonder how those warm, glowing rays are somehow captured and turned into the electricity that powers our homes, our phones, and our whole world? It honestly sounds like magic, or maybe science fiction, but it's a very real, incredibly fascinating industrial journey. Welcome, everyone. Today, we're diving into an explainer that breaks down the entire story of making electricity from sunlight. We're going to take it step by step, tracing this mind-blowing transformation from a rough rock sitting in a mountain to a sleek, gleaming solar panel. Get ready, because you are about to look at everyday sunlight in a completely different way. To really wrap our heads around this complex 18-step manufacturing journey, we'll follow a clear factory roadmap broken down into 5 simple phases: ROTI and solar panels, stone to silicon block to wafer, wafer to solar cell, and finally, cell to power plant.
Okay, let's jump right into phase 1, ROTI and solar panels.
I absolutely love the brilliant analogy our source material uses here. Think about making a roti. You don't just magically summon it out of thin air, right? You gather the raw material, wheat. You grind it into flour. You knead that flour into dough, roll it out, bake it on a hot pan, and boom, you have a finished roti. Well, making a solar panel follows that exact same logical progression. We're just swapping the ingredients. Instead of gathering wheat, we gather stone. Instead of making flour, we extract silicon. And instead of baking dough, we engineer a cell to build a panel. It's really just a step-by-step recipe, just a slightly more scientific one.
That brings us to phase 2, stone to silicon block. This is where the physical work begins.
2,000 degrees Celsius. That is unbelievably hot. Our journey actually starts up in the mountains, where a glass-like rock called quartz is mined. But here's the thing, quartz is a compound, and we only want the specific element locked inside of it. So they take this stone, drop it into an enormous electric furnace, and blast it at this extreme temperature. The heat is literally so intense that the oxygen separates and burns right off, leaving behind pure silicon. The source material compares this to extracting sugar from raw sugarcane. You're just stripping away the excess to get to the sweet spot, which in this case is the foundational element of all solar power.
Let's quickly trace these first 5 steps. First, we extract the quartz stone. Second, we hit it with that immense 2,000-degree heat to separate the oxygen. But that resulting silicon isn't quite ready yet. Step 3 is repeatedly cleaning and purifying it until it reaches nearly 100% purity. Once we have that ultra-pure silicon, step 4 is melting it down one more time. And finally, step 5, it's carefully cooled. The result? A massive, solid block of silicon. In fact, according to the text, when it cools down, this heavy block looks exactly like a giant block of ice.
Moving right along to phase 3, silicon block to wafer.
Now what's really fascinating here is the visual imagery. We've got this massive block of silicon. But obviously, a solar panel isn't a thick, heavy brick. It's flat and thin. So the block has to be sliced into incredibly thin pieces called wafers. Just picture taking a freshly baked solid loaf of bread and running a knife through it to create perfectly uniform, thin slices. That is precisely what high-tech wire saws do to our silicon block.
Let's look at steps 6 through 11 of our grand recipe. We slice the block into wafers, and then we wash those wafers thoroughly. But step 8 on the overall journey, making tiny dimples, is super clever. The manufacturing process creates these microscopic dimples on the surface of the wafer. Why? So that when sunlight hits it, the light bounces around inside the dimples and goes into the material, rather than just reflecting off into the sky. Once it's properly dimpled, we add a chemical called boron. This is absolutely crucial, because adding boron is the exact chemical step that readies the wafer to actually produce electricity. We heat it up again so the boron completely permeates the material, and then give it a final cleaning.
Next up is phase 4, wafer to solar cell. This is where we activate it. Here are steps 12 to 16. First, a protective layer is applied to prevent any loss of electricity. Then, an anti-reflective coating goes on top. Remember those tiny dimples we just talked about? Well, this coating works directly with them to ensure the maximum amount of sunlight gets absorbed. Then comes a highly precise step, drawing incredibly thin silver lines right across the wafer. Think of these silver lines as electrical highways. When the sunlight excites the electrons in the silicon, those silver lines gather up the electricity and carry it out. We heat the wafer one more time to firmly secure that silver, and finally, we test its power output. If it passes the test, congratulations! We've successfully created a single working solar cell.
And finally, phase 5, cell to power plant. Let's scale this up.
This perfectly illustrates the reality of solar engineering. A single solar cell, the exact one we just spent 16 steps building, actually produces a very, very low amount of electricity. It's really just a building block. So to create something practically useful for a home or a business, manufacturers wire together anywhere from 50 to 150 of these individual solar cells into a single grid. That combined framed grid is what we all know as one solar panel.
But the multiplier effect doesn't stop there, right? This covers steps 17 and 18 of our journey. You take that one solar panel and you group it with hundreds or even tens of thousands of other panels. You wire them all together in massive fields under the open sky. And suddenly, you aren't just charging a small battery anymore. You've created a 1 megawatt, a 100 megawatt, or even a massive 1,000 megawatt solar power plant capable of powering entire cities. And to think, it all started from that single quartz rock.
So what's really amazing is how elegantly this massive industrial process can be summarized. The explainer boils the entire 18-step journey down to just 10 simple words. Let's fire through them. Stone, silicon, block, wafer, wash, boron, layer, silver, test, solar panel. It is quite literally the ultimate recipe for modern energy, distilled down right to its essence. We've gone from a rock and a mountain all the way to the power grid, just like baking a high-tech roti. It really changes your perspective on the world around us, doesn't it? Which brings us to a final, provocative thought to leave you with today. Next time you feel the warm sunshine on your face or see a rough quartz stone on the ground, will you see the hidden electricity waiting inside? The potential is all around us, just waiting for the right recipe to unlock it. Keep exploring, keep learning, and keep looking for the magic in the everyday.